Hi, I'm Leah Jordan from CCO Studios. Today I'm here with.
Liam Power.
Patrick Hogan.
So, I heard you won a BD STEM Stars Award yesterday. Would you like to tell us about the award?
So we won Outstanding Video and BD STEM Stars, which meant we had the best submission video out of all the entries. And we'd like to thank Sarah Hurley for doing the editing for us, because we probably wouldn't have been able to do it without her.
And would you like to tell us about your project?
So what we made is a device that clips onto any pair of glasses and has three functions. It could translate LOV, which is like a simplified version of Irish Sign Language. It has a text-to-speech feature, and it could scan barcodes and list like nutritional information about the product.
That's really interesting. Do you have any future plans for the product?
Well, we'd like to expand on the LOV recognition, because right now we only have a couple of signs that can be recognized.
And we'd also like to make it smaller and lighter, and potentially even be able to sell it in the future.
That's great, thank you.
Thanks.
Hello, my name is Patrick Hogan.
My name is Matthew Furlong.
And my name is Liam Power.
We are a group of transition year students from Colaiste, Chiarain, and we would like to introduce to you our project, SmartSpecs. SmartSpecs is a pair of glasses designed to help people with everyday life. Our device can translate text-to-speech, scan barcodes giving product information, and recognize and translate LOV. Our device is designed for people who wish to communicate with LOV users but don't know any of the signs themselves. LOV is a simplified version of Irish Sign Language, commonly used by people who have Down syndrome or intellectual disabilities. Using live hand gesture recognition, our device can identify the sign and translate it into English.
LOV signing.
Our project can translate any passage of text, written or typed, into English, and it will be read out loud. Using the camera in the device placed at the side of the glasses, it captures legible text from sources like books, menus, or newspapers.
It was the best of times. It was the worst of times. It was the age of wisdom.
The barcode scanning feature allows us to scan conventional barcodes and access detailed product information, such as ingredients and allergens. Once scanned, the device retrieves product details from a food index that we developed, making it easier for users to make informed decisions about the products they buy.
This product contains 150 calories and artificial sweeteners.
We bought the 8-bit Do02 controller because of its compact design and excellent power efficiency. The controller's small size makes it easy to handle, while its ability to run for 8 hours on a single charge ensures that it can be used for extended periods without needing to recharge. The controller works by assigning a specific number to each button, starting from 0. For example, button 3 might correspond to the X button on the controller, while other buttons are mapped to different numbers.
For the design aspect of the project, we use an online computer-aided design or CAD software called Onshape. We took inspiration from Meta Ray-Bans and Google Glass, as we liked their design and small form factor. We then tweaked it until we got the optimal design. We 3D printed the prototype using our school STEM Labs 3D printer. After some testing and some conversations with teachers and friends, we realized that maybe having a full glasses model wasn't the best approach. Instead, we felt our product could have a more universal reach if it was just a device that you could clip onto an already existing pair of glasses. We made a prototype of our new design with cardboard and Lego. After some research, we settled on using the Raspberry Pi 02W for the processing, as it is small and powerful enough to suit our needs. We also bought the Belkin Power Bank 10,000 milliamps for its high battery capacity and its compact design to power our project. We purchased the Raspberry Pi Camera Module 3 to take high quality images. The Raspberry Pi 02W and the camera module will last 11.7 hours if the camera is running constantly, which it won't be. Taking into account if the Raspberry Pi is running by itself, the battery life of our device is 28.6 hours.
The language Python for the coding aspect of the project, as it allows you to easily add extensions to it. We use the Python interpreter Tony as it is pre-installed on the Raspberry Pi. To make the model for the LOV recognition, we used YOLO v5, which is an object recognition extension for Python, which allows you to create custom models for object recognition. We took pictures of us doing LOV signs, then upload them to MakeSense.ai, where we then annotate the images, which means to draw squares around them. We then export the annotated images in a .zip package in YOLO format. We gave YOLO the original images and the annotations. YOLO then uses its machine learning algorithm to train itself to look for the object. For the text recognition, we use the Python extension OpenCV. Another extension called PyTesseract then scans the image for text. For the barcode reader, we use OpenCV to open the image and then use an extension called PySbar to recognize the serial number inside the image. If the serial number matches the serial number in our database, it will then use text-to-speech to read aloud the nutritional information of the product. We repurpose an extension for making video games called Pygame to program our controller. We use the controller to select which program to execute. For example, when the A button is pressed, the Raspberry Pi will run the program to take a picture. B is pressed, the Raspberry Pi will run the program to scan for barcodes.